So there again, that's the warm-up. And now the question is, why did I have you guys warm up with this? We haven't done them in so long. Look what we're doing today. Okay. So we are continuing to solve rational equations. So last class, you were given the rational equation to solve. Today, we're looking at the application problems of it. So the first ones we're looking at are the uniform motion problems. So strategies, right? For every object, get the numerical or variable expression for distance, rate, time. Basically what we just did. These are just distance, rate, time problems. And again, what do we already know about distance? Distance is equal to rate times time. All right, which means can I manipulate my variables? All right, which would mean what is time equal to?
Distance divided by rate.
Distance divided by rate. And that also means that rate is equal to distance divided by time. Okay, so these are all equivalent equations, right, that we just manipulate around. And again, why do I like the tables, even though some of those problems might be more straightforward? Because again, they're not always straightforward. So again, having that table there to help organize your information can kind of help you to see how to go about solving it, what kind of setup we have. So for our first example, we have a motorist who drives 150 miles on country roads before driving 50 miles on mountain roads. The rate of speed on the country road was 3 times the rate on the mountain road. The time spent traveling the 200 miles was 5 hours. And so we want to find the rate of the motorist on the country road. Okay. So what are the two situations we have here? It's a good song too. We have a country road and we have a mountain road. Okay, so that's what I'm going to start with in setting up my table here. The two situations. Country road, mountain road. And again, this is a distance, rate, time. So distance, rate, time. All right, just to help me get organized here. Okay. The motorist drove 150 miles on country roads. So that's the 150 is the distance for the country road. Okay, before driving 50 miles on the mountain road. Mountain road distance is 50. Okay. The rate of speed on the country road was 3 times the rate on the mountain road. So what's the issue with that statement?
You don't know the rate of the mountain.
Okay, I don't know the rate of the mountain. So what do you do when you don't know what something is? Give it a variable. Okay, so I'm going to let m equal rate on mountain road. Okay, so the rate on the mountain road is now m. And so what does that mean for the rate on my country road?
3m.
It's going to be 3m. Okay. The time spent traveling the 200 miles was 5 hours. Okay, so often we don't end up with this total row here, but I'm going to go ahead and put that here because we have some total information. All right, so again, the total distance we know is 200 miles, and the total time is 5 hours. Alrighty. So now what I want to look at is, I know the total time. And again, we talked about distance equals rate times time, which means what does time equal?
Distance over rate.
Distance over rate. So looking at the first one, for country road, my distance over rate is 150 divided by 3m. And my mountain road, my distance over rate is 50 over m. All right. So now I can say that my time on the country road plus the time on the mountain road should add up to what? 5 hours. All right. So my time on the country road is 150 over 3m. My time on my mountain road is 50 over m. And again, they should add up to 5. So now do we just have another rational equation just like we had last class?
Yes.
Yes. Okay. What do we want to do to simplify? Okay. So before going into that, do you see anything? How about that 150 over 3?
Simplify.
Yeah.
50 over m.
Yes. So we can simplify this to 50 over m. Listen here, 50. Okay. So that gives us 50 over m plus 50 over m equals 5. And now we have a common denominator that we didn't have to create. So now we get 100 over m is equal to 5, which means 100 is equal to 5m. Therefore, m is equal to 20. All right. And again, what does m represent?
Rate on the mountain road.
Okay, that's the rate on the mountain road. So again, this is rate on the mountain road. But which rate were we looking for?
Country road.
On the country road. So therefore, what's the rate on the country road?
60.
60. So the rate on the country road is 3 times 20, or 60 miles per hour. Okay. What do we think? Any questions? Let's look at the next one. Sandy's tugboat goes 10 miles per hour in still water. It travels a total of 24 miles upstream and back in a total time of 5 hours. And we want to know what is the speed of the current. All right, so again, I'm going to go ahead and set my information up into a table. What are our two situations? Upstream and downstream. Okay. Yes. Upstream, downstream. It did give us a total, so I'm going to go ahead and put that in as well. And again, we are dealing with distance, rate, and time. Okay. So Sandy's tugboat goes 10 miles per hour in still water. Okay, so that means the rate of the boat itself. All right, so what does that say about going upstream?
It's B plus C or B minus C.
B minus C if we're doing upstream, but do we know what B is this time? Yes. B is 10, right? So upstream will be 10 minus C. All right. It travels a total of 24 miles upstream and back. The total distance is 24. So what does that tell us about our upstream and downstream? 12 each. So 12 going upstream and 12 going downstream. Okay. Let's see. In a total time of 5 hours, so again, we know this time here is 5. What else can we fill in?
10 plus C.
We can fill in the 10 plus C because we know that when it goes downstream, the rate of the current will help it. Okay, so again, we have the situation where we know the total time, and so we can create this equation over here. Time is distance, which is 12 divided by 10 minus C. And time for this one is a distance of 12 divided by 10 plus C. Oh, I meant to do that in green. Write it. 12 over 10 plus C. All right, so again, if I'm looking at the time going upstream plus the time going downstream, together that should add up to 5. All right. My upstream time is 12 over 10 minus C, plus my downstream time is 12 over 10 plus C, and again, those two should add up to 5. All right, what do we need to do to solve? Common denominator, which is 10 plus C, 10 minus C, and if we multiply that to both sides, 10 plus C, 10 minus C, 10 plus C, 10 minus C. All right, so again, this is exactly like the equations we learned to solve last time. All right, so for our first one, the 10 minus C's will divide out, leaving us with just 12 times 10 plus C. The next term, the 10 plus C's divide out, leaving us with 12 times 10 minus C, equal to, and then on the other side, I'm going to have to multiply everything out, so I'll do that in one step here. What is 10 plus C times 10 minus C equal to? 100 minus C squared. All right, because it's the difference of two squares. All right. And now, because I want to solve for C, I need to distribute everything so that I can try to isolate the C. So this will be 120 plus 12C plus 120 minus 12C equal to 500 minus 5C squared. All right. Start collecting like terms and simplifying. Something really nice happens. What was that? Yes, these terms here, they'll go away. I don't like working with negative leads, so I'm going to move that negative 5C to the other side to make it positive 5C squared. And if I move the 120 to the other side, what do we end up with? Oh, not 120. I have 120 plus 120. That's 240. So if I subtract that from the other side, I end up with 260. And then what do we do from here? Divide both sides by 5. Uh-oh, where did that just go? There it is. All right. Divide both sides by 5 by 5. That gives us c squared is equal to, what'd you guys get? 52. What's left over? Take the square root of both sides. All right, which means we're going to end up getting c is equal to plus or minus. Can we simplify the 52? Can we get 4 out? Does 4 come out? 4, 12, yeah. Yeah, that's what 4 times, is it 13? Okay, so this comes out to plus or minus 2 square root of 13. However, we're talking about the rate of a current. So what does that tell us? Cannot be negative. Okay. C cannot be negative. All right, so therefore, the rate of the current is 2 square root of 13. Were we in miles per hour? Yes, miles per hour. Or if this were a calculator problem, then we would actually solve it, and it comes out to, it's about 7.2 miles per hour. So just depends if you have a calculator or not. All right. Okay, questions on what we done? All right, I've got a couple for you guys to try. You know, I'm going to change the wording on this one because I feel like that additional is confusing. So let me change this to then. Okay. Let me adjust this a little bit. So on the first one, what's the rate of the jet?
I don't think
Anybody?
I don't think I really understand. Yeah, I said it was 400. Did anyone else get 432? Does anyone get 420?
Okay. So it sounds like
I
we
did get it right.
I got 90. Oh, 90 plus 360.
So you were almost there. You got the rate of the helicopter.
Yeah, but I got 360.
Yes.
Because I just finished it.
If the times are equal to each other.
Okay.
And then you do cross. I cross.
All right. So again, two situations, right? We have the jet, and then we have the helicopter. We have a distance, we have a rate, we have a time. Okay, the distance on the jet, 810. The distance on the helicopter, 162. The rate of the jet was 360 more than the rate of the helicopter. We don't know the rate of the helicopter, so I'm going to call it H, which means the jet is going to be H plus 360. And what do we know about the time? The times are the same. We don't know what the time is, but they're the same, so I'm just going to go ahead and put T. And then from here, distance equals rate times time, so 810 is equal to H plus 360 times T. And for the next one here, we get 162 is equal to H times T. And then at that point, do we have multiple ways we can go about solving? Times are equal, right? So that's really easy to isolate. So in this one, time is equal to 810 over h plus 360. And in this one here, time is equal to 162 over h. So now that they're both equal, you can just set them equal to each other. 810 over h plus 360 equal to 162 over h. And then how would we go about solving this one? Yeah, just cross multiply. And again, I know these numbers were a little bit bigger, so a calculator is okay on this one. 810 h equals 162 times h plus 360. Okay. I don't remember what all these numbers were. What does it come out to? 810h, 162h plus, what was that, 162 times 360? Is it 58,320? Subtract the 162h from both sides. We get 648h equals 58,320. And that means h is equal to 90. All right, and then keep in mind again, it was asking for the rate of the jet. So the jet, we'll say jet's rate equals 90 plus 360, so 450 miles per hour. And how are we doing on the second one? Anybody have that one worked out yet? Yes? What'd you get?
I got for the racer, it was 40.
Okay.
And then for the tourist, it was
Yes. How'd we do on that one? Do we want to go over that one together?
Sure.
Yes. Okay. So again, two situations here. We have a racing bike and we have a touring bike. Same thing. We have a distance, we have a rate, and we have a time. Okay, let's see. So the racer is 15 kilometers per hour faster than the person on the touring bike. And do we know what the touring bike rate is? No. I'm going to go ahead and say T is my touring rate. Okay, so T is the rate of the touring bike. So what does that make the racer then? 15T or plus T? Yeah, I'm going to go ahead and do T plus 15. Okay, in the time it takes the racer to travel 80 kilometers, so the racer is 80 kilometers, the person on the touring bike has gone 50 kilometers. Okay, and what do we know about the time? They're equal again. All right. So again, very similar to the previous one, time is equal to distance over rate. So we get time is equal to 80 over t plus 15. And this one has a time equal to 50 over t. All right. T's are equal, so we can set them up equal to each other. 80 over t plus 15 is equal to 50 over t. And again, we can cross multiply like we did previously. So we get 80t is equal to, that would become 50t, bless you, plus, oh, what is 15 times 50? 750. 750. So that's going to give us 30t is equal to 750. So we can divide out those 10s, which means the touring turns out to be 25 kilometers per hour. Kilometers per hour. Okay. And so again, for the racer, we would do the 25 plus the 15 to give us the 40 kilometers per hour. Okay. Questions on those? Is it kind of coming back? Yes? All right. Okay, so the last thing we have today are work problems. Okay, so we're talking about the rate of work. How long it takes somebody to complete a job individually, and how long it takes two people, if they work together, to complete that same job. All right, so strategies here. For each person or machine, you want to write a numerical or variable expression for the rate of the work, the time worked, and the part of the task completed. Okay, and then determine how the parts of the task completed are related. So again, keep in mind, what is a rate? Yeah, on average, like how long it takes you to do something. So when we talk about doing the rate of work, so the rate of work, we are completing one job in some amount of time. Okay. Which means that one job would take whatever the rate of work is times the time that it takes to do the job. Right. So let's look at our first one where we've got John who can mow a lawn in 4 hours. So if John takes 4 hours to mow one lawn, what can we say about John's rate? And we'll call it, I'm going to call it rate R sub J. So we know we're talking about John here, right? So how many lawns is he completing? One, and it takes him how long? 4 hours. So therefore John's rate is 1/4. Right. Penny can mow the same lawn in 5 hours. So we'll look at Penny's rate. So Penny's rate, I'm going to call her R sub P. What's her rate going to be? 1/5. Okay. All right. But we said a job is equal to the rate of work times the time. Okay. And so we're trying to figure out how long it takes them to work together. So we're going to say T is equal to the together time. Okay, so if we take John's rate of 1/4 and we multiply it by the together time, and we take Penny's rate of 1/5 and we multiply it by their together time, again, this is the job plus the job, and together they're completing how many jobs? One job. So it's one job that they're completing together. So if we clean this up a little bit, 1 over 4t is the same as t over 4, and 1 over 5 times t is the same as t over 5 equal to 1. And do we just have another rational expression like we did before?
Yes.
All right, what are we going to do to solve? Common, which is going to be 20. Multiply both sides by 20. All right, so in the first one, 20 over 4 is 5. We get 5t. In the next one, 20 over 5 is 4. So we get 4t equals 20. We combine our like terms. 9t is equal to 20, which means t is equal to 20 over 9. And what unit do we have here? This is hours. Not per hour, this is the together time, right? So this is just straightforward time. So if they work together. Now, of course, this is a contextual problem. So 20 over 9 hours, is that, what does that say to you? Yeah, so I'm going to go ahead and convert this because nobody talks about hours in terms of, oh, it took us 20 over 9 hours to work together, right? So I'm going to go ahead and simplify this, even though we don't usually. So t is, I'm going to go 9 into 20, that's 2 hours, and how much is left over? And 2/9 hours. Or if we had a calculator, we could convert it into the minutes as well. Oh, that 9 looks like a Q. Let me fix that. Okay, so what do we think of our first work problem? It's okay. I feel like every SAT I've ever looked at always has a work problem in there. All right, here's our next one. It takes Red 9 hours longer to build a wall than it takes Mort. If they work together, they can build the wall in 20 hours. How long would it take each working alone to build the wall? All right. So first, let's think about, it takes Red 9 hours longer than Mort. Okay, except do we know how long it takes Mort? No, we don't know how long it takes Mort. So what do we do when we don't know what something is? A variable. Okay, so we're going to let m equal Mort's time. Okay. So, if m is Mort's time, what does that say about Red's time? Yeah, Red's time. And what I'm going to do is do time for Red is equal to m plus 9. Okay. So that means that Mort's rate would be what? 1 over m. And I'm going to do r sub m. So Mort's rate is 1 over m, which means what is Red's rate?
1 over m plus 9.
There we go. So the rate for Red is 1 over m plus 9. Okay. So in the previous example, we weren't given the together time, but this time we are. So together, I'm going to use a capital T since I used a lowercase t over here. Together time, oops, let me write it as time first. We'll call that t is equal to 20. All right. So if we take Red's rate of m over 9, or sorry, this one, Red's rate, 1 over m plus 9, and we multiply it by the together time of 20 hours. And we add that to Mort's rate of 1 over m, and we multiply that by the 20 hours. They're working together to complete what? One job. So equal to 1. All right. So combining these, we end up with 20 over m plus 9 plus 20 over m equal to 1. And again, we just have another rational equation like we learned before. What's our common denominator? Okay, m times m plus 9. And multiply that to both sides. All right, so in our first one, the m plus 9s will divide out, leaving us with 20m. In the second one, the m's divide out, leaving us with 20m plus 9 equal to m squared plus 9m. All right, I need to get this one out of the parentheses there. So 20m plus 20m plus 180 equals m squared plus 9m. And what would we need to do from here? Combine all our like terms. All right, so over here I end up with 40m plus 180 equals m squared plus 9m. All right, I want to keep my lead term positive, so I'm going to subtract the 40m from both sides. So I have 9m minus 40m, I get negative 31m, and if I move the 180 over, I get negative 180, and this is all equal to 0, and why do we want it equal to 0? Okay, so now we can solve because I've got a quadratic here. Alrighty, does anyone see what this factors into? 5 and negative 36. I would not expect anybody to get that quickly. That one would take a little while. Okay, which means what does m equal? 36 and negative 5, except what does m represent here? It's Mort's time. Okay, well, and can Mort's time be negative 5? No, it can't be. So it can't be this. Okay. So Mort's time alone is 36 hours, which means what is Red's time alone? And we get that from doing, whoops, not 35, 36 plus 9. All right. Any questions on the work problems? Okay, that's all we have today.